In this question of kinematics, we will be learning the relationships between displacement, velocity, and acceleration. Furthermore, we will also study freeform motion in 2 dimensions. Let's take a look at this kinematics question. A Singapore soldier is undergoing marksmanship training by firing at the target as seen in figure 2 below. He uses the SAR-21 rifle, which has a muzzle velocity of 900 meters per second. Well, the muzzle velocity is the velocity at which the bullet exits the rifle. He ensures his rifle is perfectly horizontal while aiming for the head of the target. He then fires a bullet at the target, which is 300 meters away from his current position. There are 2 parts to this question. Calculate the time taken for the bullet to reach the target after it is fired, and what is the assumption made in this calculation. Let's draw a schematic diagram of the question. So we will have the soldier who is 300 meters away from the target. So the target is here, and the horizontal distance is given to be 300 meters. Now with the distance, we need a speed, and we can calculate the time. So the distance is given 300 meters, speed is 900 meters per second. We can proceed to calculate the time taken. So the horizontal distance is the horizontal speed times the time. So the time will be the horizontal distance over the horizontal speed. And substituting the values given, 300 over 900 is calculated to be 0.333 seconds. Seems to be a quite simple calculation, but there's one crucial assumption that is made in the question. Alright, in answering this question, we have assumed that the horizontal acceleration is 0, and this will imply the horizontal speed is constant and it does not change with time. And what leads to the horizontal acceleration to be 0? No air resistance. Because in the presence of air resistance, the bullet may slow down. And AX, the horizontal acceleration, will not be 0. So we are treating this question to be in the ideal situation where it is in a vacuum. The bullet does not experience any deceleration. Let's look at another part of the question. Assuming that it is a perfect shot, which means that the rifle was perfectly horizontal and was aimed properly at the head of the target. Calculate the vertical distance between its aiming point and where the bullet actually hits the target. Again, let's draw a diagram to show what is actually happening in this question. So, let's assume this is the bullet and the target is here. The bullet, right, is 300 meters away from the target. And what happens is the bullet does not travel in a straight line. In fact, it is traveling in a parabolic path. So, what is the parabolic path? This is the parabolic path, something like this. Why is it traveling in a parabolic path? Because gravity pulls the bullet downwards. So, in the vertical direction, the bullet actually undergoes acceleration due to gravity. That is why there is a vertical distance that we need to calculate between his aiming point and where the bullet actually hits the target. So this is his aiming point, indicated in blue dot here, and The actual point where the bullet hits the target is indicated by the red dot. So in between, so this distance is the vertical distance. Sy we need to calculate. So this is two-dimension kinematics. Now, since we already mentioned there is no acceleration in the horizontal direction, vertically there is acceleration due to gravity, we will use the equations of kinematics in the vertical direction to solve for this vertical distance. So the formula we're going to use is Sy equal to Uy t plus half Ay t squared. Do we know the values for all the variables used in this formula? Yes, we do. So for the first variable Uy, it is equal to 0. Why is it 0? Remember, the question states that the bullet exits the rifle with a horizontal velocity of 900 meters per second. The soldier is holding the rifle horizontally. So that's why there's only the initial horizontal velocity of 900. There isn't any vertical velocity. So the vertical velocity initially is 0. Now the bullet takes 0.333 seconds to cover a horizontal distance of 300 meters as calculated in the previous part. This vertical distance that we're going to calculate also takes the same time to be covered. Hence, the time here will be 0.333 seconds. It's the same time. The same time elapsed but covering distance in two dimensions. The horizontal distance is 300 meters and the vertical distance is the one that we're going to calculate. Then, Ay, since we already know it is acceleration due to gravity, we will substitute it to be g. And time again as 0.333 seconds squared. Now upon calculating, we will find that the vertical distance is 0.544 meters. Let's proceed to the next part of the question. After passing the target, the bullet is entrenched 4 meters deep into a sandbag that is directly behind the target board. Calculate the average deceleration of the bullet as it moves within the sandbag. Now, how are we going to tackle this question? There are a few assumptions that we need to make to solve this question. First of all, after the bullet has hit the target board, we assume the bullet still assumes a speed of 900 meters per second horizontally. So this is the first assumption we make. There's no slowing down of the bullet after passing through the target board. The deceleration only occurs when the bullet is in the sandbag. Next, notice the question asks for average deceleration. So the next assumption we have to make that the deceleration is constant within the sandbag. And this entire motion occurs in a straight line. So these are the few assumptions that we need to make. Now, what is the kinematics equation that we need to solve this problem? Let's list down the variables that we know. First of all, we know that the final velocity horizontally of the bullet must be 0 because the bullet comes to rest ultimately. And the initial velocity horizontally of the bullet is 900 meters per second. The acceleration horizontally within the sandbag is what we need to find. And we are also given a piece of information that the distance horizontally is 4 meters. The bullet moves a distance of 4 meters before coming to a stop. So these are the four variables that we have here, and only one of it is unknown. And from these variables that are listed, it is very clear that we can use this formula. Vx squared is equal to ux squared plus 2ax dx. This is the formula that we need to use. Let's substitute all the values that we know. So Vx is 0 squared, Ux is 900 squared plus 2. Now Ax is what we need to find. Dx is given to be 4 meters. Then upon calculating, the horizontal acceleration is very huge. This is what is calculated to be. It's rather a big magnitude. 101,000 meter per second square is the average deceleration. Notice there is a negative sign. This negative sign will indicate that it is a deceleration. So if we want to write the answer, we will say that the average deceleration is equal to 101,000 meter per second square. But if we are stating the acceleration, then we need to include the negative sign. Now let's come to the last and final part of this question. If the assumption was not made in B part 2, state whether the bullet would hit the target at a lower or higher point than what was calculated in B part 3. So let's recap what we already found in B part 2. Now what was the assumption made in B part 2? If you couldn't remember, we state that the assumption is air resistance is equal to 0. So now the question states that if air resistance is no longer 0, means assuming air resistance is present, what will happen to the bullet? If air resistance is present, then the bullet will slow down. This will imply the bullet slows down. Now once the bullet slows down, what will happen to the time taken to reach the target board? The time taken to reach the target board naturally will increase. Meaning the bullet needs a longer time to reach the target board. If a longer time is needed to reach the target board, will the vertical distance covered be larger than before? Yes, because more time means the bullet has more time to travel downwards. So the SY, or the vertical distance covered by the bullet, will increase. Hence, the bullet will hit the target at a lower point, as calculated in B part 1. Then what was calculated in B part 3? So schematically, how would this question look like? So let's have the bullet and the target board as shown. Initially, we assume air resistance is negligible. So the bullet will travel in something this path and hits the target here. Now, with air resistance, the bullet travels slower than before. So it will not move so fast, and it will slant further downwards, as shown. Hence, the vertical distance covered is much greater than before. I hope with this question, you have an enhanced understanding of kinematics. Thank you.